Hello everyone, welcome back to my channel, Ma'am Balot's Math Tutorial. Today we will be discussing the tangents and secants of a circle. Let us recall first what is a tangent line. It is a line that intersects the circle at exactly one point. So if this is a circle and line AB intersect the circle at point C, then line AB is a tangent line. And point C there is what we call the point of tangency. What is a secant line? It is a line that intersects the circle at exactly 2 points. So if we have this circle and we have line AB intersecting points A and B on the circle, then line AB is what we call the secant line. Let us have the different theorems and angles formed by tangents and secants. Theorem number 1. If two secants intersect in the exterior of a circle, then the measure of the angle formed is 1/2 the positive difference of the measures of the intercepted arc. If we have this figure, line segment AB and line segment AC are secant lines, and arc DE and arc BC are two intercepted arcs of angle BAC. Then we can say that the measure of angle BAC is equal to 1/2 of the measure of arc BC minus arc DE. So for example, if your arc BC measures 140 degrees and arc DE measures 30 degrees, then the measure of arc BAC can be computed as 1/2 times 140 minus 30 degrees. Computing further, we can have 1/2 times 110 degrees, which is equal to 55 degrees. Thus, the measure of angle BAC is equal to 55 degrees. Theorem number 2. If a secant and a tangent intersect in the exterior of a circle, then the measure of the angle formed is 1/2 the positive difference of the measures of the intercepted arcs. So we have this figure, and line AB is a tangent and line AC is a secant. We have arc BE and arc BC are two intercepted arcs of angle BAC. Then we can say that the measure of angle BAC is equal to 1/2 of the measure of arc BC minus the measure of arc BE. If the measure of arc BC is equal to 260 degrees and the measure of arc BE is 80 degrees, then the measure of angle BAC can be computed as 1/2 times 260 degrees minus 80 degrees. Subtracting the angles, we have 1/2 times 140 degrees, which is equal to 70 degrees. Thus, the measure of angle BAC is equal to 70 degrees. Theorem number 3. If two tangents intersect in the exterior of a circle, then the measure of the angle formed is 1/2 the positive difference of the measures of the intercepted arcs. So if we have this figure, lines AB and AC are tangent lines, and arc BDC and arc BC are two intercepted arcs of angle BAC. So according to the theorem, we can have the measure of angle BAC is equal to 1/2 of the measure of arc BDC minus the measure of arc BC. So if arc BDC measures 290 degrees and arc BC is 70 degrees, then the measure of angle BAC is equal to 1/2 times 290 degrees minus 70 degrees. Subtracting the angles, we have 1/2 times 220 degrees, and it is equal to 110 degrees. So the measure of angle BAC is 110 degrees. Theorem number 4. If two secants intersect in the interior of a circle, then the measure of an angle formed is 1/2 the sum of the arcs intercepted by the angle and its vertical angle. So if we have this figure, lines BE and CD are secant lines. Arc DE and arc BC are two intercepted arcs of angle BAC. So from the theorem, we can say that the measure of angle BAC is equal to 1/2 of the measure of arc BC plus the measure of arc DE. So if arc BC measures 40 degrees and arc DE measures 60 degrees, then the measure of angle BAC can be computed as 1/2 times 40 degrees plus 60 degrees. So adding the angles, we have 100 degrees. And 1/2 of 100 is equal to 50 degrees. So the measure of angle BAC is equal to 50 degrees. Theorem number 5. If a secant and a tangent intersect at the point of tangency, then the measure of each angle formed is 1/2 the measure of its intercepted arc. If we have this figure, line AB is a tangent and line BC is a secant. Arc BC is the intercepted arc of angle DBC, and arc BAC is the intercepted arc of angle ABC. So according to the theorem, we can say that the measure of angle DBC is equal to 1/2 of the measure of arc BC. If arc BC measures 210 degrees, then we can have 1/2 times 210 degrees, which is equal to 105 degrees. So angle DBC measures 105 degrees. And also, the measure of our angle ABC is 1/2 to the measure of arc BEC. If arc BEC measures 150 degrees, then we can have 1/2 times 150 degrees, which is equal to 75 degrees. So the measure of angle ABC is 75 degrees. Now let us have the theorems on intersecting chords, which states that if two chords of a circle intersect, then the product of the measures of the segments of one chord is equal to the product of the segments of the other chord. So if we have this circle and we have two chords with the corresponding points, then line BE and line CD are secant segments that intersect at point A. So from the theorem, we can say that the measures of DA times AC is equal to EA times AB. So if the given measures of AC is 12 centimeters, DA is 5 centimeters, EA is 7 centimeters, so we can find now the measure of the segment AB by following the theorem. So substituting their measures to our equation, we can have DA is 5, AC is 12, and EA is 7. So multiplying 5 times 12, we have 60 equals 7 times AB. So to solve for the length of AB, we need to divide the whole equation by 7. So we have now AB is equal to 60 over 7, or equivalently, this is equal to 8.57 centimeters. Let us define first what is an external secant segment. It is the part of a secant segment that is outside the circle. So if we have this circle and this is the secant segment intersecting at point C and B, so AB is a secant segment and our external secant segment is the line segment AC, which is actually outside the circle. We'll have now the theorems on secant, tangent, and external secant segment. Theorem number 1. If two secant segments are drawn to a circle from an exterior point, then the product of the lengths of one secant segment and its external secant segment is equal to the product of the lengths of the other secant segment and its external secant segment. So given this figure with two secant segments with these corresponding points, so we have AB, which is a secant segment, times AD, which is its external secant segment, is equal to AC, which is the other secant segment, times its external segment, which is AE. So given the measures now, DB is equals to 10 centimeters, AD is 4 centimeters, AE is 6 centimeters. What is now the measure of AC? So substituting to the equation from the theorem, we have now AB is 4 plus 10, which is the whole secant segment, times 4, which is the measure of AD, is equal to AC times 6, which is the measure of EE. So adding 4 plus 10, we have 14. Then 14 times 4 is 56. And then we divide the whole equation by 6. And we get AC is equal to 28 over 3, which is equivalently equal to 9.32. Theorem number 2. If a tangent segment and a secant segment are drawn to a circle from an exterior point, then the square of the length of the tangent segment is equal to the product of the lengths of the secant segments and its external secant segment. So we have this figure and we have these points. So AB is a tangent and AC is a secant line. Thus we have AB squared is equal to AC times its external secant segment, which is AE. So given the measures, which are EC is 14 centimeters, AE is 4 centimeters, what is now the measure of AB? So AB squared is equal now to 4 plus 14, which is the measure of AC, then times 4, which is the measure of AE. So adding 4 and 14, we have 18, then times 4, it is equal to 72. So to solve for AB, we need to get the square root of both sides. So AB now is equal to 6 square root of 2. Now it's your turn to answer your learning activity sheets. I hope you learned something from today. But please don't forget to like and subscribe. Thank you so much. At your service, Ma'am Balot.